Hello, everyone, and welcome to part 3 of section 1.3. Today, we are going to finish up this unit by talking about function families and different function characteristics. Here on this first page of our notes, you're going to see a bit of an overview of what we're going to hit today. So we have 4 different function families over here. And by the end of today, our goal is going to be able to recognize function families from graphs and equations. We're also going to talk about these different characteristics of functions. We'll have increasing, decreasing, and constant. We'll talk about absolute, maximum, and minimum, and then we'll also talk about x-intercepts and y-intercepts. First thing we are going to look at is kind of a brief description of each function family. So here we have the linear function family first. This is probably the one we're the most familiar with. So I'm really just going to sketch a couple lines because we should have a pretty good idea of what linear functions look like. We will fill out this general characteristics section as we go through talking about the other characteristics, but first we're just going to write line because linear functions are lines. The standard form of a linear function is f of x equals mx plus b. So we know that slope-intercept form already. Any equation that we see that's written that just has a plain old x in it is going to be a linear function. So that's what we're looking for when we're looking at equations, to identify them as linear. For exponential functions, these are going to be a little new for us. Exponential functions have this smooth curve shape. We usually describe them as a smooth curve. So I'm going to add that to our characteristics section here. They can be there's 4 different kind of directions that they can go. They can go up to the right, down to the right. They could even be flipped over like this. Notice they each have kind of this part that looks like it's flattening out. That's a special characteristic of an exponential function, but it kind of gives you an L shape. So that might be an easy way to remember what it looks like. Then their standard form equation for exponential functions is going to be a times b to the x plus c. So the super important thing to remember for exponential functions when you're looking at an equation is that x is in the exponent. So we're going to make a note of that over here as well. X is in the exponent. That's what makes it an exponential function. So that's the most important thing you're looking for in an equation to determine whether it's an exponential function or whether it fits in a different function family. The next 2 are quadratic. So a quadratic function is going to be a U-shaped function. They can be upwards facing U or downwards facing U. They are U-shaped. We'll add that to our characteristics. The word quadratic has a U in it, so that might help you remember it. Their standard form looks like f of x equals ax squared plus bx plus c. Those letters A, B, and C, those are just placeholders where numbers would be in regular functions. So those are just variables that they pick for the standard form of the function. The part that stays the same, that has to be there in order to make it quadratic, is the x squared. So if any function has an x squared in it, that is what makes the function quadratic. So x squared is what you're looking for to make sure the equation is quadratic. And then our 4th function family is linear absolute value. So linear absolute value, underlining the V, because their shape is a V shape. I bet they did that on purpose, whoever made this up. So absolute value functions are a V shape. I'll make sure my V looks like a V. So they're V-shaped. One thing, I'm going to draw this, but then I'm actually going to erase it. Notice I didn't draw for either of these examples any functions that were sideways, because I actually misspoke right there. If I drew these sideways, even if it was a V, these fail the vertical line test. So they're not functions. So they don't fit the term function family. So that's why the quadratic functions would only be upward facing or downward facing. Same thing with V, a regular V or an upside down V, but not sideways. Okay, then we've got the standard form, lost my word, of absolute value functions. These are probably the easiest ones to tell in an equation because they have those absolute value bars. That's the giveaway. So any function that has those absolute value bars, it's going to be V-shaped. It's going to be in the absolute value family. So those are our 4 function families. And as we go through today, we're kind of going to look at different characteristics of them now. So one set of characteristics that we're going to look at first is whether they're increasing, decreasing, or constant functions. And we'll start with the definition of an increasing function. So an increasing function is a function that goes up from left to right, over the entire domain. So a couple little sketches of what an increasing function would look like. If I have my x and y axis here, I could have a linear function that's going up from left to right. So I read it just like I would read a sentence or read a book. I start from the left, go to the right. So as I follow my line here, I see that it's going up from left to right. Exponential functions can also be increasing. This would be an example of an increasing exponential function. So it starts on the left, goes up to the right. Decreasing will do the opposite. It will go down from left to right. So a function that goes down from left to right over the entire domain. So a couple examples of a decreasing function. A line that's decreasing would look like this. That has a negative slope. That's another way to think about it. And then a decreasing exponential function could be one that looks like this. So as I drew it from left to right, it's going down, left to right. And then finally, we can have a constant function. So a constant function, the word constant kind of should start telling you something. It means something's not going to change. Something's going to be the same. The thing that stays the same or that remains constant is the y value. So it's a function where the dependent or the y variable doesn't change. So that means, for example, let's say I'll use a y value of 3. A constant function is going to look like this, a horizontal line that goes through a certain y value. So as I trace and find points on this function, I notice everywhere across that line, the y value is 3. It never changes. So that's what makes a constant function. So constant means y value doesn't change. Sometimes our functions can be a combination of increasing and decreasing. They could even be a combination of increasing, decreasing, and constant. That just means that they do both on the same function. So a function that both increases and decreases in the same function, in the same graph. So an example of that might be this quadratic. So as I am going from left to right to read that function, I see here it's decreasing as my pen goes down the left side. But then once I hit this middle point, it changes to increasing. So as I trace it back up, it would be increasing. So that's what a combination means. It means it does both on the same function. Another example of that would be an absolute value graph. As I go left to right, as I go up here from the left to the right, I'm going up. That's increasing. But then I hit this point in the middle and it changes to decreasing. So that's what it means when it says a combination of both. We can even have like crazy looking functions that do all of the options. So they could be increasing, constant, increasing again, change to decreasing, constant, but that wouldn't fit one of our function families. So that's just a little extra example there. So that's like one group of characteristics. Another group of characteristics are the absolute maximum and the absolute minimum. An absolute maximum, think about what the word maximum means. It should make you think of like something that's the most. So an absolute maximum is the highest possible point on a function. So it reaches a peak of some sort. It's a maximum. Another way to look at it is it's the point or the ordered pair with the highest y value. So think about it as like a mountain peak or a hilltop. Example. Let's see. I'm going to give us an actual like coordinate to use. So let's say I have this absolute value function that has a point up here at 1, 3. We would call that point right there the absolute maximum because it's the highest point that function reaches. Then we can also have something called an absolute minimum. So minimum, you would think the lowest or the least of something. So it's kind of the opposite of the maximum. It would be the lowest point, lowest possible point on a function. It's the point with the lowest y value. That would be like a valley. Ooh, whoops, I left the E off. So if we are thinking about the opposite of our absolute maximum, that means my function needs to be like flipped over. So I'm actually going to use a quadratic example this time. And let's say we have a point at -3, -4. Oops, I meant to write that over there. -4. In order for this to be an absolute minimum, my function would need to go up from that point like this. So it would be like an upwards facing U. It could also be an absolute value graph. Either one, quadratic and absolute value, both can have a minimum or a maximum. So this point right here at -3, -4, that would be our absolute minimum. And then the last two characteristics we wanted to review with you are x-intercept and y-intercept. So x-intercept would be where the function crosses the x-axis. And then for y-intercept, it would be where the function crosses the y-axis. Crosses the y-axis. So if my function was a line or a linear function, my x-intercept would be this one point right here where I just put that dot. If my function was an absolute value function, I would have two x-intercepts. For a y-intercept, if I had, let's see, an exponential function maybe, I would just have one y-intercept there at that point. And for a quadratic function, I still only have one y-intercept. So there's a couple examples of each of those. Now, the last thing I'm going to go through is I'm actually going to go back up to the function families little area where we started and add some characteristics here. So for lines, for linear functions, one thing I want you to add, now that we know what these things mean, is that a linear function can either be increasing or decreasing, or it could also be constant, but it's only one of those at a time. So you would say like this one right here would be an increasing function, that example. This one would be decreasing, and this one would be constant. Another thing that I want y'all to add is that with lines, with linear functions, there is no max or min. We are always going to have arrows at the end of our function when we're talking about like just a regular old linear function with no restrictions or anything, no endpoints. It's going to have arrows. So that means it's never going to reach a highest point or it's never going to reach a lowest point because those arrows keep it going on forever and ever. For exponential functions, these will also either be increasing or decreasing. They can't be constant though. So up here, this one would have been increasing. This one's decreasing because it's going down left to right, increasing because it's going up left to right for the last one. These will also have no max or minimum. And then with quadratic, the U-shaped functions, these will be a combination. They'll always be a combination of increasing and decreasing. That U-shape forces them to do both. Ooh, that was funky. Increasing and decreasing. These can have either a maximum or a minimum. It'll have one or the other. So this example right here would be a minimum because it's a low point. And this would be the maximum. It's the high point, the top of the hill. And then finally, for our absolute value functions, these will also be a combination of increasing and decreasing. Combination. So Like this one, it's decreasing to start with, and then it changes to increasing. This one would be increasing, then it changes to decreasing. And these will also either have a maximum or a minimum. After y'all watch this video, we will take some time to do these go over the practice questions together. So y'all try to get through those practice by identifying the function family by what you're seeing there, and then we'll go over those together.